Good morning. Welcome to Mission Control Houston. This is the International Space Station Flight Control Room, and the folks you see here make up the Orbit 2 team of flight controllers, which is working with Commander Drew Feustel and the Expedition 56 crew as they finish up a busy work week on orbit. The combined American, Russian, German crew spent some time this week dealing with a small leak on the station. They also got ready for the upcoming spacewalks and arrival of a Japanese cargo ship, both of which are due next month, as well as working on some science experiments and completing another milestone in the field of biological studies.
We have a beautiful looking flow cell, and we can tell by all the data coming in that RNA is being sequenced. So thank you and congrats again for being the first person to sequence RNA in space.
Welcome to Space to Ground. I'm Isidro Reyna. A historic milestone was achieved this week on the International Space Station. NASA astronaut Ricky Arnold successfully sequenced RNA on board the station as part of the biomolecule extraction and sequencing technology experiment. This has the potential to be a game changer for research into crew health and understanding how organisms respond to spaceflight. The investigation studies the use of sequencing for the identification of unknown microbial organisms living on station and for understanding how humans, plants, and microbes adapt to living on the orbiting laboratory. This knowledge can provide better insight into the development of requirements and procedures necessary for human exploration, both on the station and in future exploration. The International Space Station's cabin pressure is holding steady after the crew conducted repair work on one of two Russian Soyuz spacecraft attached to the complex. The repair was made to address a leak that had caused a minor reduction of station pressure. The crew was never in any danger. After a morning of investigations, the crew reported that the leak was isolated to a hole about 2 millimeters in diameter in the orbital compartment or upper section of the Soyuz MS-09 spacecraft. Flight controllers in Houston and Moscow worked together with the crew to effect a repair option in which Soyuz commander Sergei Prokopyev used epoxy on a gauze wipe to plug the hole identified as the leak source. Flight controllers continue to monitor station's cabin pressure in the wake of the repair. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
Did you ever see a cancer experiment up close? Well, you're about to. Recently, flight engineer Serena Onen-Chancellor turned on a camera while working with the Angie-X cancer therapy experiment in the International Space Station's Destiny Laboratory module, and gave us a look as she grew and examined endothelial cells, which are important in the human body's blood supply system. Scientists want to know if the space-grown cells can improve testing methods for drugs which are aimed at choking off blood supply to cancerous tumors in the body.
Hey, good morning and welcome to ISS. Today I am working on the Angie-X cancer trials up here on ISS. We've actually spent quite a bit of time working on this. And what we're looking at here is something called an endothelial cell. And an endothelial cell, you find these cells in every blood vessel in your body. And so people wonder why we're growing these cells up on ISS. And scientists believe that cells in the body grow very similar up here on ISS. A lot of times scientists try and grow these endothelial cells in the ground and they don't live for very long. And they think for some reason they grow better up here in space. And that's one of the things we're testing on orbit here. And you can see some of these cells right here on the computer. So why is this important? Well, endothelial cells help form blood supply. And tumors need blood supply to get bigger and bigger. And all of us have had someone impacted by cancer, whether it's a family member or a friend. And so we're always thinking, how can we fight this cancer? Well, one thing we're looking at is, can we grow these cells on orbit to test new cancer drugs to prevent that blood supply from growing? And if we can stop that tumor blood supply from growing, then we can help beat that cancer. So that's just one of the science experiments we're looking at here on the space station. This is where all the cells live in their biocell habitat. And when we're done working with them, we put them in something called Sable 2, which is up in the ceiling for ISS. And it feels all nice and warm and comfortable because it is, because it's just like the temperature of the human body. And so we let the cells live and grow there, and we've had them for almost 2 months now up here on ISS. We feed them, we give them nutrients, and they basically live, they're like miniature crew members living with us. So we're going to this new biocell, which is delta 7. And these biocells here have been treated with varying levels of a cancer chemotherapy drug that is being tested out here on ISS. And so we are looking at the cells, the researchers look at the images that I take for them on the microscope to see how well that drug is impacting the connection between those endothelial cells to see if it will stop this tumor blood supply from growing. Make sure that's level.
Main position to Forrest and Face Slider at the leftmost position for the first image.
And you can see some of these tubule formations here also.
Good spot.
Yeah, I agree, it's a good spot. You do see definitely some of the tubule formations here and some of the gaps in between the cells.
Really good representation of both of those. That's a really good spot.
Now, serving as a one-of-a-kind laboratory for scientific research is a big part of the mission of the International Space Station, providing a place for experiments that cannot be done on Earth. But another station goal is helping us prepare for future human exploration of space, and the rodent research experiments covers both of those goals. Rodent research is a twofold investigation into the treatment of muscle loss in spaceflight, which may have implications for patients on Earth with muscle-wasting diseases. The experiment studies the effectiveness of a drug compound as well as the nanochannel drug delivery implant.
We're testing the drug as well as the device. Sarcopenia or muscle wasting is a big burden on the healthcare system currently. So the results from this study will provide us with valuable information on understanding the mechanism of action for the drug that we're testing. Now, the other unique aspect of it is the nanochannel delivery system that is implanted in the mice.
These nanochannel membranes are microfabricated with the same type of technology that you use for make computer chips. Because we have realized that if we take channels that they are that small and we use them as a rate-limiting membrane, we can achieve a very steady and controlled delivery of the drug without any sort of pumping mechanism on board of our implants. So that makes a very small, very effective implantable delivery system.
The big goal is that we're making humanity better and we're helping our generation and the next generations live longer and better. So at the end of the day, if we can accomplish that, it makes it all worth it.
The laboratories at the International Space Station are not the only place on this vehicle that supports scientific research. The outside of the station is home to a number of experiments, and that includes the new Total and Spectral Solar Irradiance Sensor. That's continuing NASA's decades-long work of gathering important data to help researchers who are looking into changes in Earth's climate.
Follow the Sun. Presented by Science at NASA. The sun. It inspires songs, warms us, and grows our food. Life on land and in the oceans, the daily weather, and long-term climate patterns happen primarily because of the energy we receive from our closest star. Even tiny variations in that energy can affect the workings of our planet's atmosphere. NASA uses instruments to follow the sun and monitor the amount of solar energy coming to us. The latest instrument to do so, the Total and Spectral Solar Irradiance Sensor, TSIS-1, makes those measurements with unprecedented accuracy. TSIS gathers information from its perch aboard the International Space Station, or the ISS. flying on the platform that the orbiting laboratory provides has allowed TESIS to continue NASA's 40-year record of tracking the sun's radiant energy, one of the longest and most important climate data records gathered from space. Over the past several decades, Earth's ice mass has diminished, sea levels have risen, drought and precipitation patterns have changed, and growing seasons have shifted. To understand the causes, including human influences, of these changes, and to refine the models used to simulate Earth's climate, researchers must know the amount of incoming solar energy. Peter Paluski, TESIS lead mission scientist, explains, when there's a balance between incoming energy from the sun and the infrared radiation Earth emits, climate remains steady. An imbalance means energy is either being stored in the system, causing temperature increases, or lost, causing temperature decreases. Energy from the sun makes up half of the balance equation. Even though the measurement record shows that the sun's solar energy output has not had a major influence in recent climate change, that output needs to be monitored continuously. It is arguably the most important variable we need to know to understand climate, says Paluski. Trying to understand climate without measuring the sun's input is like trying to balance your checkbook without knowing your income. Climate is measured over long time spans, decades to centuries and longer, unlike weather that changes over small time scales. To be able to connect measurements over long time periods, continuity and accuracy are key. TESIS has two sensors. The Total Irradiance Monitor, as its name suggests, measures all of the radiant energy from the sun, and the Spectral Irradiance Monitor measures how that energy is distributed over ultraviolet, visible, and infrared wavelengths. The latter helps scientists understand where in the atmosphere solar energy is being absorbed. For example, TESIS spectral irradiance measurements of the sun's ultraviolet radiation are critical to understanding the ozone layer. Ozone in the stratosphere absorbs ultraviolet light. This heats the stratosphere and drives changes in atmospheric wind flow that can propagate down to the lower atmosphere and impact climate. So many factors influence Earth's climate, says Paluski. We need to continue learning how they all interact. TESIS is helping us characterize the sun's behavior and how Earth's atmosphere responds to the sun. For more science from the International Space Station, go to www.nasa.gov/ISS-science. To continue following our closest star, visit science.nasa.gov.
In supporting plans for future space exploration, the International Space Station is letting the engineers who are developing the spaceships of the future work out the issues with the systems they're designing to support the astronauts who are going to make those trips beyond Earth orbit one day. Systems such as those that will provide clean water. In the latest installment of the STEMonstration video series, Station Commander Drew Feustel discusses the water recovery system used to recycle crew wastewater for consumption.
Hi, I'm NASA astronaut Drew Feustel. Welcome to the International Space Station. On our station, our water recovery system is vital to our mission and our survival. Want to know why and how we recycle and filter our water? Let's go. We use water recovery and filtration because it is expensive to launch resupply missions, and the weight of the water is a problem as well. Think about the weight of a single bucket of water. Can you imagine the weight of water for a month's supply for 6 people on the International Space Station? What about the water for a year or more when we leave low Earth orbit for deeper space missions? That's a lot of water, and bringing it with us is not very efficient. On station, we recycle wastewater to get fresh drinking water. This recovery and filtration process includes our urine, moisture we exhale, and sweat, along with the water we use to bathe and shave. It works like this. When we use the bathroom, urine is collected and pumped to a distillation assembly. The assembly spins, pulling the urine to its walls. The urine is heated to evaporate water from the waste and then condensed in the outer chamber to form distillate. Next, the water is pumped to a tank where it is joined with the water recovered from cabin air created by crew sweat and respiration. Down the line from there, odors and any other contaminants are removed with heat. Then iodine is added for microbial control. Our water is checked often to ensure it meets water quality requirements. It is also monitored closely for bacteria, pollutants, and proper pH. The pH scale ranges from 0 to 14 and is a tool used by scientists to measure the strength of an acid or base. Our water is required to be in the 6.0 to 8.5 range. The end result of the entire process is clean drinking water that we get to enjoy every day. The recycled water on the space station is sterile. There's no odor or bad taste. You've seen that water recycling is critical for long-duration missions, such as here on the space station, and will be for future trips to the Moon or Mars. Be sure to check out the activity connected to this video so you can learn more about water filtration. Thanks for learning with me, and I'll see you next time.
This demonstration videos have been produced during this year of education on station to help teachers and students get the most out of learning about science, technology, engineering, and math. You can find all the videos at that address, nasa.gov/STEMonstrations. You'll also find the lesson plans that support them and educational resources to learn more about research and technology on the International Space Station. The STEMonstrations are part of the International Space Station's education mission, which includes opportunities for students on Earth, from elementary school right up through college students, to talk to the crew members while they're in space. Station has a live television capability as well as an amateur radio setup for those events. And last October, flight engineer Joe Acaba made an historic contact with the Maria Montessori Institute Educational Unit in San Cristobal, Venezuela. It was the first ever educational ham radio contact in that country's history, courtesy of the Amateur Radio on International Space Station program. Here's a look at the excitement on the ground as more than a dozen elementary and middle school students got their chance to talk to a man in space.
Latinoamericana, con el fin de que el contacto pueda ser hecho en español.
Para nosotros poder establecer la comunicación debemos ver a la estación espacial y ella debe vernos, o nuestras antenas se deben ver. Entonces tenemos que superar las montañas que nos rodean.
¿Por qué? Porque indudablemente si hubiera sido en inglés, pues también tiene un impacto, pero no es el mismo impacto que se llevan los muchachos. Bravo, Kilo. Can you hear me? Yankee 2, Charlie Mike Romeo, November Alpha 1, Muchísimas gracias y bienvenidos a todos a la Estación Espacial Internacional y estoy listo para la primera pregunta. Over.
As we've mentioned, the International Space Station is not only a home for science, but it's a tool for getting humans ready for their next step out into the cosmos. That future trip will be on board the Orion spacecraft, which is being developed here in Houston. The latest in a series of tests to evaluate how well astronauts and ground crew can get out of Orion in an emergency on the launch pad was completed here at the Johnson Space Center's Space Vehicle Mock-Up Facility. Data gathered in a series of test runs will help engineers evaluate the design of the capsule and refine the procedures to make sure that everyone will be evacuated as quickly as possible in those cases where the launch abort system is not required to be activated. Things such as a crew illness or the presence of fire or toxins in the crew cabin.
We have to have the procedures to do that, and the vehicle has to be built in such a way that they can quickly get disconnected from the vehicle. This testing is really to go set all of those situations up and see if we're designed to the point that we can get the crew out within 2 minutes.
Specifically testing emergency procedures. If there's any sort of emergency called, we want to make sure that both the flight crew and the ground crew can get safely out of the capsule and away from the stack. Orion is supposed to take these crew to Mars, so we need to make sure that we have a design that supports operations from the launch pad all the way through deep space, and it's important that we keep the crew safe so that they can return home to their families.
NASA has made no secret of the fact that, from time to time, we're inspired by popular culture. That includes Star Trek, which from its first run in the 1960s has inspired generations of scientists, researchers, astronauts, and some non-science majors too. Now, some of the fictional concepts that appear in Star Trek are actually being researched and utilized on the International Space Station.
Science and Star Trek go hand in hand. For 50 years, Star Trek has inspired generations of scientists, engineers, and even astronauts to reach beyond their grasp to help create a future for humanity with limitless potential. Let's take a look at some of Star Trek's science fiction concepts that are now a little closer to being science fact, thanks to our very own International Space Station. Warp drives, phasers, and transporters might be what you picture when you think of Star Trek. But some of the show's other scientific concepts are actually being researched and utilized aboard humanity's laboratory in the sky, the International Space Station.
The International Space Station is a science laboratory in the unique environment of microgravity.
It allows you to do research that's impossible to do on the surface of Earth.
And that is going to allow us to make breakthroughs in ways we've never done before.
So we can live better and create new technologies that we can bring back here on Earth.
And the money spent out there in space is investing in our future right here on Earth.
Measuring the planet now, Captain. Spheroid-shaped. Atmosphere. Oxygen, nitrogen.
Earth.
Star Trek, they would scan the planet for life forms and the atmosphere, for example.
All of those same things that the Enterprise would observe, we're able to observe from the space station.
We have a variety of atmospheric sensors on the space station.
And really looking at Earth from up there, it shows you a lot of things that you cannot see from the ground.
We're learning more about the Earth, about how clouds form, about the winds and how those create hurricanes,
how our planet behaves.
We can understand the potential implications of climate change.
Looking at the atmosphere for signs of life.
Population change.
Human impact on Earth.
And this is what space gives you, a perspective that you cannot have here on Earth.
So we're moving to the point where, yes, you can say, scan this planet. It's a little fancier on the Enterprise, but the fundamentals are the same.
got 14 science labs aboard this ship. The finest equipment and computers in the galaxy.
Much like the Enterprise, the International Space Station is home to a state-of-the-art laboratory.
The space station is a unique place for doing biomedical research.
Also, working in a weightless environment allows researchers to take gravity out of the equation.
It opens up new research areas to scientists who have never studied this kind of phenomenon.
So we can get insights into those processes that we can't get back here on Earth.
There's amazing things that are being discovered.
It allows for the development of new medicines, new treatments for various diseases.
And really improving the quality of our lives here on Earth.
Gentlemen, there is one thing which requires the immediate attention of all of us. Specifically, our future.
Star Trek was really a big part of space exploration today because it's in all of our souls.
We all share a curiosity about what's beyond the horizon.
People gravitated towards Star Trek and found the inspiration there to go on and become scientists and engineers and make their contributions.
So the youthful scientists at NASA are conceiving things that the older people never thought of, never occurred to them.
We're making great discoveries, and we're laying all that foundation for the dream that Star Trek really represents.
We want that to be true, and so we're working really hard to go make that happen.
Research aboard the International Space Station is advancing knowledge of our bodies, our home planet, and our understanding of the cosmos. But we've only scratched the surface. There's an entire universe of scientific discoveries to be made, and with that knowledge, who knows how far we'll go.
If you would like to get another look at any of the stories you saw here this morning, check us out on YouTube and on Facebook. There are the addresses in the ever-present blue box. And while you're at either one of those places, take a look at all the other cool stuff you can find out about NASA and America's human spaceflight program. You should also check out Houston, We Have a Podcast, which features folks here at NASA talking about their work in all aspects of space exploration. The new episodes post on Fridays. Today, August 31st, the fourth part of our series on the hazards of human spaceflight. Gary Jordan talks with Peter Norsk about how the altered gravity fields that are encountered on a long flight out into the solar system can impact the combined system of the human body. Go to www.nasa.gov/Johnson/HWHAP. Houston, We Have a Podcast. You can find all the episodes there. You'll also find them on Apple Podcasts, Google Play, and SoundCloud. This is Mission Control, Houston.